Welcome back, everyone, and today is just another progress video for Fungai's refactoring and rebuild. I kind of skipped one. I was going to stop one once I have the engine rebuilt, and then do that, then work on armatures, but I decided to kind of I didn't have time to record, so I kind of just kept going with the development, and I'm kind of mostly done with armature systems. So this is going to be, I'm going to try to do this really quickly, but there's a lot to show that Fungai has really changed a lot since the last video. Last video is really just the core API of just a wrapper around the WebGL 2.0 APIs, and just kind of like putting things together, how to build buffers, how to do how to render, do some basic rendering, things like that. But in this version, big changes, a lot of changes. They're really experimenting a lot. So let's kind of go really through it. I cleaned up the files now. They're still kind of a little messy. I want to get rid of the lib file at some point, get rid of the old folder, and maybe do something with files because it's kind of a big horrible mess in there. But for right now, I have some new, everything is like the new structure is kind of there. Like we have the Fungai, which contains the main stuff, and then everything will have its own little module folder. So armature has its own, and then miscellaneous. And I have a new folder called notes, where I'm going to start keeping all my little bit of notes, like math notes and codes and little bits in here. I need to clean this up a little bit, but the code base is starting to get cleaned up. So in the Fungai, last time we left, all we had is the core folder. That's really all we had. It was just core, and it still has all the basic stuff. I think, like how to do this without anything. Just the core folder, no math library, no nothing. Just plain and simple. So the core is actually very minimal. You only have the cache, you have dynamic buffers, material shaders, UBOs, VOs, and GL. That's it. That's all we need to get just rendering. And then after that, I decided to now let's build up the engine. So I created a folder called engine. I like the idea. Like I wanted a core to be separate and run on its own, and I want engine to be something the same thing, that it runs on its own, but it has dependencies on core and the math library, essentially. And the math library is pretty much the same. I kind of just fixed up Quantorian and I think Matrix 4. We have transform. Transform is a new data type. It becomes the most important data type in the new Fungai. It's something I was doing with in the previous version, which I was kind of moving into doing less with matrices and less with dual Quantorians, and more with transform at its core base, where you have the rotation, position, and scale. And now transform becomes like first class citizen. It's its own data type. It's its own object. It is basically the backbone of the new engine. That's where a lot of the main math comes in, and it helps with armature, because that was one of the problems with the last version. I was dealing with armature system. The way I had it built, kind of like a mix and match between matrices, transforms, and dual Quantorians, was a big mess. It was very hard to manage and to get the world position when I want to do inverse kinematics. So all that got cleaned out. I still have matrices and I still have dual Quantorians, but that's the final product of a transform. Everything is done with transform, and then when I need to go to a shader, I'll create either a matrix or dual Quantorian based on what I need. If it's a 3D mesh, it's a matrix. If it's armature skin information, it's going to be a dual Quantorian. But everything gets stored as transform. And now it's not a mixed bag. I don't have a world and local matrices and dual Quantorians. I don't do that anymore. It's purely transform. Primitive folder, very bare minimum. Which is good because you don't need too many primitives. But I might put back some old ones that I had, like the wedge and cylinder and things like that. I would like to maybe have a pill shape again. But for now, this is what you need. I just need the floor, I need the quad, and I need a cube face for testing. So the engine's kind of like the big part of this big update. And as you can see, it's very minimalistic too. That's really the whole driving force of this refactor, trying to trim the fat out of Fungai, because I felt like in the past 2 years I've been putting so much fat in it and so unorganized. I needed to be slimmed down a lot, and I felt like I did quite a good job. And the engine now feels more like an engine instead of just piles of code that kind of just works together because they just luckily enough work. As you can see, in a lot of the previous versions, I've always used fungi as the root thing, and I don't do that anymore. Fungi is just a name. It's just a prototype thing. It's an open source project. You don't have to name this fungi. It can be whatever you want. The engine can be whatever you want. That's why I wanted the core to be separated from the engine itself, so you can build new engines. Especially since the last 2 years has proved to me that I spent a lot of time rebuilding fungi. Every year I build it twice. So engine really should be something that's completely separate. It's something that I can change and redo because new paradigms, new ideas, new concepts come in, and it feels like the engine needs to be done in a different way. Like ECS really changed how I perceive how an engine should work. And ECS now becomes, again, just like Transform, first-class citizens. So in the engine we come in, we have the ECS library put together, and I fixed that up. I change entities quite a bit. Everything else kind of stays the same, but entities are still different. And a lot of things that I've changed, everything's went to more functional programming and data-oriented programming. And that's what this big change is. It's the thought process of object-oriented to going for more data-oriented and a little bit more functional instead of just everything is just objects. And everything is still kind of objects. When it needs to be, but it most likely it's always going to be functional. It's going to be stuff. So the entity I have, like I have the constructor. As you can see, I have something called info now. Now entities, I wanted to get rid of the com component, because every time I wrote like an entity, I had to say e.com and then the component name. I wanted to get rid of that because that was just so much code to write. It was just, to me, it was just a pain in the ass. I'd rather just say e.transform.something, e.bone, and that's it. I don't want to put com. I don't want like this middleman. So everything that was at the root was kind of like the ID, the name, and active. Now it's kind of under a component called info, or like a structure called info. And that basically becomes like a pseudo default component that exists in entity. The root of the entity object is open to be inserted new components, period. So the entity object now, instead of having properties and methods, is essentially an empty container that you can throw anything you want into it. And that, to me, makes the code base when you're actually writing the code and building this engine a lot easier. Because, like I said, that .com, like that .com thing is something that you kind of have to do if you're building like something in a high-level lower language, like C# or C++ or Rust. So you need a way to contain things in certain ways. But this is JavaScript, and everything's more variant, and there's no typecasting. So take that to its advantage, and just say, okay, entity is an empty container. You can throw anything you want into it because it's just a plain empty container. It makes a certain bit a little bit more complicated like that, because before I liked having add component as a method, but I can't have that as a method because that becomes part of the empty container. So the container isn't really empty. There's the info component, then there's this couple of methods. So if I want to like loop through the objects like prototype or something, I will find all these methods in there, and I don't want that. I just want to be able to loop through the entity at some point, and all I see is just components, nothing but components, no methods. So that's the thing I had to change about entity. Some of these object like methods had to become like static functions. So you have to pass in your entity component, and then it does the function. So that's the only little drawback. But a lot of this stuff happens in like these other functions, like these little wrappers. So it's not something you do very often anyway. So it's a balancing act. I want the API to be very clean, but at the same time I want to be able to use it. Clean and usability, I think sometimes it's hard. It's a hard balance, in my opinion. So ECS took a big change. Render loop is almost the same. App is big because before I had the app, I had fungi, and I had API. all of that has been combined into one file, and everything's been cleaned up, tightened up, squeezed, and to a bare minimum. So the app actually is not a very long file. It's to me it's a lot short. So this is the fungi functionality, which was just global objects, and everything just lives in an app now. My API, I didn't really have much. So this is API, and this is all I really need. When I was rebuilding the engine, this is the only global functions I need. I need a way to create an entity node and a draw node, a node entity and a draw entity. That's it. That's really all I really need on a global scale for functionality. And I'm experimenting with something I just did like maybe 2 or 3 weeks ago, is that any function that basically initializes an entity, like adds components to it and configures a new component, I'm going to label it with a $. Because I have like systems or other components. Let's see, if I go to the ECS folder, in ECS folder, I only have very, very bare minimum components. If I say go to draw, is it in here? No, I guess I don't. I forget which component has that. I think the armature system is like really where you see it. Let me just go to armature system really quickly. Go to armature. So like I have the armature component, and instead of just saying init or build or add or whatever, I'm just going to say armature.$, and you pass in the entity container, and that's it. So anytime you see a $, it basically means you're going to initiate, you're going to build, or you're going to configure an entity. So this way, instead of writing those words, it's just a single symbol. It's less to write. I know it's a little abstract. I'm using a $, because there's only 2 symbols you can use as function names. $, and something else. I think underscore. And I don't want to write underscore. So $, I only had 2 options. So $, it is. So anytime you see a $, function, that's the initial. It just initializes a thing. Like I said right here, I pass entity. It checks to see if armature exists. If it doesn't, it says entity.add, and then returns the entity, and you're done. Very simple. So I'm just experimenting with some ideas. It's like, to me, I like it. It's less code to write. Once I make that, like, okay, that's the rule, it's easy to remember. Again, an app is very simplistic, and I'm doing a lot more work with not permissions, promises. I really stepped up my usability of promises, or like being more creative of how to use promises. So like the launch is very bare bones. It uses a promise, async, and await. You know, it initiates GL, then initiates ECS framework, and if we have an on draw event, we create the looper, the render loop. I'm experimenting with the idea of having like use things, like use something, like certain systems that I want to just make. Like before, I had like a function, and I would have to call the function to initiate it. And this time, I don't feel like doing that. I'm experimenting with something kind of like something like what C does is we can have like if definitions, like if defined, do this. So I'm kind of doing it like that. So if defined used armature, load up this, and then throughout the app, there's actually a couple places where it checks to see. Here, I'm checking to see, am I using it? So I'm actually going to load in armature and armature preview, and it's actually using a bitwise operation. So if I can say this, say yes 1, which means true, it's going to load in the armature file, and it's going to run a function that I have called run module init, which is a cool function like that actually just loops through that module that gets downloaded. I'm looking for something that ends with the system, and if system has like a function called init, it just calls it for you. So this way I can load in ECS systems very quickly, very easily. I actually have an extra function called load modules. I pass an array of modules, and it automatically calls, loads them in dynamically, and then calls the init function. So this way I can have systems. I can load in systems and plugins or whatever very, very quickly in this version. I have load scene. It's kind of the same. Depending on what settings you have, it's gonna bring in the floor. So this way, if I want to, I can start like a GL instance without any of this crap turned on if I don't want it. So I need at least the camera, and I probably need the input, but maybe I don't want the floor, and I don't want debugging or anything else. And debugging is new too. Debugger. I had various experimentations with how debugging. The debugging is still the same. I still have points and lines and cubes and all these other things. But I just always kept experimenting with different ways of how to load it in. And this time I decided just something simple. It just make it a global object that exists in the app, like an app object, like global object. So this way, anywhere in Fungi, if I import app, I automatically have access to debug if it's turned on. If debug is turned on, I can access this anywhere. So I was like in the last version, I had to create the debug like point or the line for every page I needed it. Now I can just turn it on, and it's available globally for that instance, which to me it makes it so like it's made it easier to develop. So I don't have to copy functions into the page and then do the debugging stuff and then copy them back into the module. This way I can just import app, use the debug, and then take out app if I don't need it for that module, and I could do it for debugging. So debugging, like visually debugging, is a lot easier. So impact tracker. So let's look at some other code, like some code like test cubes. As you can see, everything is different now. The page is super bare bones. There's no more HTML on any of these pages at all. It's basically the entire page is the bare minimum HTML, and then straight into the JavaScript. App now builds. Actually, no. I have like a library. I made a simple library called Page, which essentially just builds the HTML for me in JavaScript. And like I said, it uses like no, it doesn't. I thought it used promises, but so it creates it copies over the CSS files and everything else. So this way, the entire layout is built dynamically, and I have something built out so I can have 2 columns. So this way, I can have like the view and then a side column for I can put user controls. So later on, I want to be able to put user controls for some of these experiments, like some UI. Not UI that's floating. It's kind of like part of the page. It's kind of like a left panel or a right panel, like Blender. Downloader has been changed very much, especially when it came to armature stuff. I came back and redid Downloader twice already during this iteration, because I'm doing a lot of GLTF stuff now, and I also wanted to build Downloader to be kind of independent. There is no imports. It's self-contained, because I have a new job now. I'm actually kind of a graphics programmer, essentially, in real life now. I'm not just doing this for fun as a YouTuber. Sorry if this made bumpy sounds. But so for work, I have to use Three.js, and I'm building things, and I'm thinking, like I want to be able to use some of this stuff at home, instead of rewriting it for Fungi. Let me just build it where it's super bare bones, self-contained, and I can reuse it for I can reuse it for anything. So the Downloader is more self-contained, and it handles it's more plugin-ish based than the last version, and my XR connection can handle instead of like adding one item to a queue. Especially when I want to load in 3D models, especially with GLTF, I need like a JSON file and a bin file, like a binary file. And I was doing it what they want you to do. You download GL file, you go into it, you parse it, you look for all the bin files that are associated with it, and then you go download all the bin files. That's silly. That is a silly way to implement something. If I know this JSON file and this bin file are together, Why do I have to go into that JSON file, parse it to find this? The download process becomes actually very complicated. So I was like, like I said, at this point, I want to get rid of complications. And every GTL file I've been using so far has only one bin file. So I just automatically built it where I can say, it'll probably be in this test file. This one isn't using, it's using like the first prototype. But like I'm saying, I want this file and I want this file, and it happens in one download session. So it downloads this. So it basically every connection has its own mini queue. So this way when it adds it to the download complete, it says, well, for this instance, you've downloaded this file, and it's a certain type. Like it's like type shader. So like up here, like this API changed quite a bit. Let me go to a simpler page. So the way like downloader works now is basically I have to mark, say, do I need resources for download? So yes, true. And then that means the next then function is the downloader promise. So now that I have the downloader promise, I'm going to use it and say I want to download a couple of things. So I have shader, so it's a shader type, and I say what file I need to download it. Same thing if I was going to say GTLF, I'll just say GTLF and file 1, file 2, file 3, file 4, and those are all the files that get downloaded for just that one GTLF. And then when it's done downloading, I guess this example shows it. Well, I'm done downloading it. What do I deal with it? And as you can see, there's an array of files that were downloaded for that one download instance. So this way I can group files together as a single download item and then pass that single download item to loader functions. So like GTLF always is going to GLTF. Yes, GLTF always is going to need 2 files, maybe 3, maybe there's like 4 bin files for some reason. So I made it super like easier to download. And the download function, the download before, you had to write all this JSON stuff, and I found that to be super silly after a while, because now I'm creating this object in memory that, you're creating this object in memory that you're just gonna loop through and then use add functions. I'm like, you know what? I mean, just to build the API, where instead of doing that, I just do it this way. Just call a bunch of, I'm going to call these functions anyway. So this way I don't use a loop. I don't create this object. Everything's slimmed down. Like I said, it's like it's more optimized. It's more slim. It's easier to use. It's just, to me, I like this. So this way I launch, everything's cool. I say I need to download resources next. And so the next thing is, well, you need to download. Here's a promise for the downloader. Downloader, I have a promise. I said, all right, let me add files to the downloader, start it. This automatically, the next then executes when the downloader is completely done. At that point, the downloader also has its own loader. So it actually loads everything for me. So I don't need a second step. So that's done. Now I can just say, well, I want to load some new modules. I want to load Armature and Armature Preview. It loads Armature, that creates another promise that returns back. Well, when that promise is done, I have this one. It's like, well, okay, we're done. You're done loading all these modules that you asked to load up for you and to initialize. Well, load scene is another promise. Boom. So some things use multiple promises, and I do things in parallel, and then I do a promise wait all. But I built everything around promises when we're initializing Fungi, and I kind of like it. It's very simple. It's more the API feels cleaner, and I'm not building extra. I'm not making extra things that doesn't need to be there. Let's see, this is 23 minutes long. So what else? Another big thing in this new version of Fungi is ECS draw component. There's two big things. First thing, let's talk about node. Before I had the transform and I had a transform node. Transform was basically just to handle all the transform information. Transform node was to handle all the transform stuff related to hierarchy. Having two components dealing with local transform and world transform was a nightmare when it came to Armature. It's complicated. It's like I wanted the idea of where hierarchy was optional. It was optional. If an object did not need hierarchy functionality, let's not bother having it. Save some space, some memory, whatever. This time around, I said, you know what? Hierarchy is required. Even if an object doesn't need it, you're stuck with it. It's kind of like the first version of Fungi. I kind of had it built into it one way, and then decided to break it out. I'm going back to it. I tried, I experimented, I found out that it's probably not the best idea. If I want transform and hierarchy transform, I should all keep it together and don't try too hard to break them out. If you really don't need the separation, then don't bother. That's what I learned. Oh, and something you'll notice with this node class. I asked suggestions from the last video, and I totally forgot what some of the suggestions was. I do implement some of them. One suggestion someone asked me is like I should try to do JavaScript doc, and this file is kind of an experimentation of me experimenting with writing documentation in JS doc. So this way, I can use it down the line for something. So I'm just experimenting. So this is one of the only file that really like fully documented, just to experiment. It tells you what the module name, the version, the author, and what each one does, and what the properties are, and some of these are actually kind of useful because sometimes I forget what some of these properties are, and it's kind of neat to have that. I haven't found a really good plugin for Sublime Text that uses JSDoc for IntelliSense. Like that's kind of like one of the reasons I would want to do this, because then this will define IntelliSense for me automatically. But I haven't found a good plugin yet. So if anyone knows a good plugin for Sublime Text that can handle that can take that information and then use IntelliSense, like so I can just. I would love to be able to just type in the math library and say vec3 and automatically get a list of functions, and then like with the order of all the parameters. That's what I would love to do. It would be easier because a lot of times I have to go back to the file, look up the function, and I would love to have IntelliSense. But I love Sublime Text. I don't want to use any other text editor, to be honest, than Sublime Text. So I need a good plugin that can do that for me someday. But I suffice. Let's go back. So Node is now transform and transform node merged together, just node. And I like to use the word node because it's simple. It's very easy to type. And the constructor, as you can see, is very simple. I have it still is modified. You have to set manually. I have the local, which is the local transform. Here's the world transform and the model matrix. Model matrix is there's no more local and world, like I said before. It's just for caching the transform for shaders, because if an object does not move that often, I don't want to have to recalculate everything for the matrix. So it's just really just a caching mechanism. And then you have the stuff for hierarchy, and again everything. And the way I built hierarchy this time around is in such a way that I'm actually managed to simplify it like a lot. Before I had to do a calculating we'll get to it when we get down there. The way I did transform parenting and the mathematics for it was very complicated because I'll get to it. We'll get to it to the very end. Like, because that's kind of a big thing, and it worked so well. I will get to it. All right. So transform is important. Like I said, it's like one of the most important things in here, and this is what transform all it is. It's just rotation, position, and scale. And it handles all the things for it. How to add one transform to another. So this one updates. This transform, use this transform to transform a vector. So this way I can get the world transform of an entity and then do some vertice calculations on it, transform it. So something that's in local space becomes in world space and things like that. It becomes very useful when I do inverse kinematics. And then like a function, how to actually add it together, like how to add a transform together. So it becomes, this, like I said, becomes its own data type. It becomes very important. And so you have a local and I have a world. And world is not something you modify manually. It is something that's auto updated through the system. And the ECS system actually handles a lot of it. So you don't have to really do this. So it should be like a private type of thing. So I like underscore it or anything. But I want, like, sometimes I might need to access it. So I want to leave it easy and simple. But I do say it right here. It's calculated by the node system and it's updated by You know, it's not something you have to manually do it. You only modify local. And to make typing and things easier, I have setters and getters. And set pose, which sets the pose, excuse me, of course. So I have like set functions, and it allows me to set is modified for me. I have the same thing for add pose. Sometimes I just want to add a position, add to the position. I do a lot of that sometimes, so this way I make a function easier. I also have, since JavaScript doesn't allow types and I can't have like different constructors, I do things like this that says that you know if the first argument, if there's only one argument, that most likely means you're passing in a vector. So that's what it's doing. It's kind of tricky. I think I have it up here. So this, like I said, JS docs actually is pretty cool because actually it can document that. So you can see X can either be a number or it can be a vector 3. Set rotation, set local rotation. I use that a lot. Just set rotation in general. Set scale. A lot of you people might be like, why is everything in these tiny ass shorthand? Because I like column depend. I like to column align everything, in case you haven't noticed. And even though rotation and position are the same, oh my god. Even though position and rotation are the same amount of characters, scale isn't. And I thought that I write this crap so much. I want to shorthand and everything, so this way I have less code. And really, it just, like I said, that's one of the big things. I want to make less code. And then you have functionality for how to add a child, how to remove a child, get direction. You know, so this way you know what forward. It basically uses the world transformed or the. This one kind of calculates the world rotation for you, and then you know, can give you the like forward, left, up direction. So it's important. Sometimes you want to know which direction you're looking at. And let's see. And update world transform is super simple. Like the last version, can I find it? I'm pretty sure I could. If I go to fungi input, fungi mod, no, it'd be. I forget. I just threw everything in old that I don't need. Well, let's suffice it to say it's super simple. If the parent exists and the parent has been modified, this child itself that you're currently updating is going to be set to true. If it's not, you were exiting out. In the previous version, I had something called is parent modified, because the system would actually set this object's the system for the transform would set is modified to false because I don't know, because I just wanted to do that. I wanted to be clean. I wanted it to be self-contained, and that made certain things more complicated. Setting is modified in one system. You know, do all the math and then say, okay, I'm done updating this thing. If I don't set, so I came to a realization when I was rebuilding this. If I actually get rid of setting is modified at the end of the system, this allows me to completely skip, throw out a bunch of code. Just by changing that idea, is like, don't set is modified in the system. Do all the updates. So and the system, the node system, loads everything with a sort. So when you do a sort, it every sorts by level. So this way, parents come in first, then all the children come in first. So you update all the transform in the proper order, which makes super easy. And like instead of calling that function, I have everything built inline. So this way, I'm not calling the function like 1,000 times. I'm just doing the code. So it's like a duplicate. But like I said, it's very simple, bare bones. I don't need to do anything anymore. I don't need to keep track as his parent or like before. I used to say is modified equals false. To simplify things, like I even wrote myself a note. Like to simplify it, like I took out a bunch of code in here. To simplify it, I just made a new system called cleanup, and all it does, it loops it yet one more time, and set everything to false. That's it. That's it. And you'll be surprised how important this becomes after I did this, and how much of a realization this is, because especially when I'm dealing with the armature system, I'm going to do modify as well. So this way I can actually, let's say I can do a bunch of things and set things as modified. So after like this is done, like if I'm done doing all the transform modifications, I have like other systems that deals with like armature stuff. And by keeping is modified set as true, that's been modified, I can the armature systems can say, well, this bone has been modified. I'm going to go update the previews and things like that. It becomes super easy. So this way, keeping is modified state true until after you're done rendering the scene makes the entire pipeline more simple. So that becomes very important. Like you should keep in mind that maybe these states should be not modified at each stage. They should be modified after you're sure that you're completely done needing that state. So so basically the idea is like for every frame, this state should be reset. You shouldn't reset it in the middle of processing a frame. Reset it when the frame is done. So this way you can actually use this for other systems. So it becomes super important. So that's one of the most important big changes I did to Fungi is breaking things out a little bit. So I have other systems called cleanup, and when you see armature systems, armature system is the same thing. If we go to armature system. Armature system has the same thing. It has like a bone system now. I have an armature system. Then I have a cleanup. So I can run a system on bones and then keep the is modified state, and then armature system will actually piggyback and use that state too for other things. And then when all said and done, after the frame is done, I call armature cleanup along with node cleanup. So it's an extra two system that runs after everything happens. And by following the same idea, armature preview system, piggybacks on other things as well. It checks to see if armature is modified. Because before, the armature system would set modified as false, because after it's done doing its thing. But now preview runs after armature, so this way it piggybacks on that modified state. So like again, it simplifies things. Before I had to do things in weird orders and everything else, but I think building this another time really taught me some really cool things. Some realization of how to build ECS frameworks. Or how to really utilize ECS frameworks and things. And the last big thing I did for Fungi is draw. I need to be able to draw. There's a big thing that I want to do, and it's coming up, and I'm actually started experimenting with, is that I need draw objects to share the exact same transform. For example, when it comes to the armature system, right? The armature system is I need the mesh that handles it. I need the armature system itself that I need access to the world transform. And then I have the preview that I need access to the world transform. And each thing, it can be different draws. And certain effects, I need to do the same draw. There's like I need to do multiple draws. Like let's say I want to do an outline. That means I need an outline of a character. I need to render the mesh as an outline, like to scale it and then render it like flat. And then you need to render that exact same mesh again on top of it as your regular rendering. So that's a two draw calls. So instead of having two entities and then trying to keep them together, I just like, you know what? The draw component can have multiple draw objects, and those draw objects all share the same entity transform. So if I load an entity for drawing, I load in the model matrix and everything else, and I just draw all the items that belong to it. Same thing when it comes to characters. I started downloading characters from Sketchfab, and I started realizing certain objects, like certain things, are broken out in pieces. Like sometimes you have the head that's separated, the face is separated because you want to texture the face separately, but it's still assigned to the same bone structure. So keeping the draw calls as draw items in the draw component. So this way they can be one component that's inside of an entity instead of having a bunch of different entities under a parent entity. That means you have all these extra transforms and all this extra objects. So I thought it made it super easy to actually just draw things. And one test example I have is inside here would be test cubes. Test cubes is I have two entities. They're parent under each other, but each entity has two draw calls. The one draw call actually draws the cube, and the other draw call uses the exact same VAO but draws it as points. So this way you have the points and then the actual faces colored at the same time. But each cube is a single transform. So here I have 4 draw calls, but only two model view matrices between them. So before in the previous system, if I want to render the points, they have to be their own entity, and that means they get their own world transform. And it would have to then parent that. They don't have to create. Then they would have to create several sets of parenting. It becomes a very big problem. This one is just I have the parent, the main cube, and the sub cube is just a child to that cube, and it's done. It's very simple. If we look at the code, and another thing that I'm actually doing is I'm building like these little test files inside every part that's important. So here's how that page is put up. I say, well, I want a face cube. Give me its VAO. Right? And then I say, well, I want a draw component. And the draw component allows me to pass in one set of draw information. So here's a VAO, here's the shader, and this is the draw mode, this would be triangles. The draw component has a method, say add. So I say, well, here's the VAO again, but here's a different material, which I saved up here. I create a new material dynamically, and I say I want the draw mode to be points. So it's like I say, it's the exact same data, but it's a different draw call with using a different material and a different draw mode. But they all share the exact same transform. And then I create the subcube, and then I just say, well, I want to make B the child of A, and start the loop, and I'm done. The end, and this rotates. So there you go. So that becomes like an important aspect. So drawing becomes super easy, and I can do more things with it in the future. I don't know if other engines do that, but I know like Unity and stuff, they have multi-pass shaders. So maybe the shader system is what handles that. Here I don't have a shader system that does that. I have the draw system that handles that. So like the way I build a system is different than how other engines do it. I might be doing it wrong. There's very good reasons for it, but so yeah, and there's like test pages. So I have like test debug. It shows you all the features of the debug. Another nice big thing I did is I redid the camera controller. The camera controller is super smooth because I've been using 3GS and their engine. Their camera controller is really smooth, and I looked at the source code and I figured out how it works. And the idea is that it's basically a lot of the same thing I was doing beforehand, but instead of being constantly pointed to like an object, I have a target position, and I move that target position, and the camera just stays a certain distance away from that target, so I can pan, and then I can pan around, and I can't see where the target is. It'd be kind of nice to just maybe display where the target is, but now I can, because before when I would pan and then I would orbit, it would spring me back here, and then I'm orbiting the object. And going over is not as bad. Before it was like really crazy. Now it kind of does like weird bounce, but whatever. But like it's less, and it's just overall easier to move. I love this. Before going forward would be I would go through the floor, but now forward actually just moves the target. So like I said, all I do is I'm moving a target, and the camera just keeps looking at that target, and it allows for ease of use so it's just easier to traverse the 3D space. So the camera controller has been changed quite a bit. So that's one great thing. So we're pretty much done. I have the miscellaneous. Miscellaneous has a couple of new objects. GTLF. I have the GTLF loader. I rebuilt the GTLF loader. Before it was kind of a pain in the ass to use, but the GLSFL loader, like the parser and everything else, is super smooth. And it's simple. And it's bare bones too. I made it super bare bones. It pulls out information in kind of a simple structure, and then you can use the structure in any engine you want. So this GTLF loader can be used in 3GS because I do use it in 3GS. So I built it to work on any JavaScript engine you want. It just parses the GTLF file and the bin file that comes with it. It becomes super simple. Go to Armature. Like I said, Armature system is now working again. As you can see, the bones, the skinning, and scale all work together, which is great. And to finish it all off, to really show you, like I'm actually testing with GTLF. This is really, it's not the final test. This is actually an old file. I can load in stuff better now. But here we go. We have a 3D model that I fixed up from. I found a model in Sketchfab, and there were some problems with it. So I spent like 2 nights fixing it up. That there was problems with scaling, and some of the bones were kind of screwy. Like I couldn't. It wasn't. It was good enough if you want to animate inside Blender, but it wasn't good enough if you need to import into a game engine and you need to animate on it. There's a lot of extra garbage in there. It just wasn't game engine friendly. So I spent 2 nights on it. I optimized the hell out of the object. I fixed up all the scaling issues, all the position issues, all the skinning issues. I learned quite a cool things about Blender. Blender has some features how to clean weights. Because when I was loading in the data, like see here it says weights. I used to have like 3 sets of weights. So it was weights 0, 1, and 2 inside the GLTLF because there were like the chest bone was assigned to the chin, and the neck was assigned to the chin, and the head was assigned to the chin, and other things were assigned. So some vertices had more than like 4 bones attached to it, but for most game engines, the limit is 4 bones. So, Blender apparently has a feature where you can clean up, and the thing is, a lot of the bones were 0 influence; they had 0 weight. So, Blender does have a feature where you could say clean weights, which actually clears any bones that has a value of 0, or you can actually set a default value. So I set like if it's less than 0.0001, get rid of any weighted bones. And Blender also has another feature where you can say limit how many bones each vertice. Because when I cleaned it down, then I still only had 2 weight objects to deal with. Then I went and fixed. Ran it like everything like 2 or 3 more times, and I ran it with the feature that says like limit bones or limit like bone count. I forget what it was, but there's a feature in Blender where you can actually say limit how many bones each vertice can have. So I set it to 4. I ran the clean thing again, and I got everything slimmed down to a single weights object. So it's like a Vec4. That's it. So weights and joints, all that stuff got cleaned up like crazy. And as I can see, I can pose it, and because Vegeta's not supposed to be looking up, and the arm should be in a T shape. It's a T shape. So we're gonna be now that the engine is working, Armature is working, and bones and everything else is working. The next step is I need to get inverse kinematics working. So if I can get inverse kinematics, and I'm not going to build the entire inverse kinematics system that I had with all the solvers, I'm going to stick with just the limb solver first and just get all that working beautifully. Work all the kinks, get the API working, and get the limbs API working, and maybe the arc one so I can do arcs with with the spine maybe, because the spine has more than like has 1, 2, 3, has 4 bones. So I need something more archy. I don't need to work on the animal leg or the animal piston one. Mostly just deal with the limbs first, and so I can do some inverse kinematic stuff with Vegeta. Have his arm reach out and grab things, and maybe do something with his head where he has look animation. And I want to do the dynamic dance too, that I prototyped a month or so ago. But inverse kinematics is the next stage. If you want this Vegeta file, you can go to the Patreon. You can go to the Patreon Sketchpunk. You do not have to pay me. I absolutely don't have to. It's absolutely free. You can come in here and you can download the blend file and the GTL and bin file that's already been perfectly exported for WebGL. So those two can also be imported into Unity or Unreal Engine if you want. But like if you're going to do web projects with 3GS or Fungi or anything else, these two files are exactly what you need to load up. And like I said, everything's cleaned up. It's in T pose. It has no textures. If you want to add UV textures, go for it and pass me the file so that I can do textures too. Down the line, I might do the same thing. I might just do UV so I can texture certain parts of the body. So it's like basic textures, like texture that white, texture his clothing blue, whatever. But I was thinking about using Vegeta as one of my test subjects for prototyping, because it's a pretty good bone system, and I was able to clean it up and use it. So, and it's a complete nice skeletal bone structure. It has shoulders, has hands, has feet. It's a nice simple skeleton. I try to use another one that's called Venom, like a Venom character, but they had weird bones, and I would actually have to reskin that that model for me to be able to be usable in a game for me, or to make it usable with WebGL. It was just too much of. It was kind of more of a mess than Vegeta. So I was like, you know what? I love Vegeta. And it would have been easier because, like I said, the bones and everything else I didn't have to do. I just had to clean up the weights and stuff. The bones itself were fine. I didn't have to redo the bones. I took out 2 bones. That's about it. There were 3 bones. Yeah, I think I got rid of 3 bones. No, wait. Yeah, I got rid of 3 bones. This is the old file. There's the toe bones were kind of useless, and this bone on the head that's useless. It's not assigned to anything. They're just endpoints. But yeah, I got rid of those 3 bones and everything. And I think every fingertip has the same thing, has an extra bone that doesn't need to be there. So I got rid of everything. Like I said, it was important for WebGL to have less transforms and keep things as smooth and simple as possible. And this video is already 52 minutes long. So yes, you really want Vegeta, go for it. Fungi has been updated onto GitHub. So it's just my GitHub/Fungi. And you can get the latest version of the engine. It works really well. I'm trying to make sure it works on Firefox, but I haven't been testing it lately. So it should work, hopefully. I need to start testing on Android because I want this to work on Android as well. As you can see, this little post that has this dancing robot, that's where I'm trying to get to. I want Vegeta to do this. So in case you haven't seen my prototype that I've been tweeting about like a month ago, this is the inverse kinematic system doing a dynamic pose, dynamic dancing. So, so I got like I said, I got the armature system all working and everything's good. Now I just need to get IK working, and then I can try to rebuild this with Vegeta dancing, and that's gonna be so sacrilegious, it's not even funny. But I digress. So that's where we're trying to get to. We're trying to get Vegeta to do that. Vegeta, you need to start dancing for your stuff. And that's it. So that's the Fungi update, and it's a very long. I'm sorry. Yeah, I don't have a lot of Patreon posts. The only Patreon posts I really do are like 3D models that I've created myself, and yeah. So Yeah, you get assets. That's it. But I don't have really much assets. Patreon is really just a tip jar, essentially, for my YouTube videos. So there we go. So I'll probably do one more progress video once IK Systems is working, and maybe when I have the dance working too. Maybe I'll make sure the dance will be like the actual the final example of it working. Then I can start going back into doing full-time tutorials. But today I'm actually going to try to record one small tutorial. So let's see. So yeah. So I can see if I can do that tutorial really quickly because I need to go somewhere because it's Sunday and my family's waiting for me. So yes. So I'll see you guys in the next video, and hopefully you guys are enjoying the progress of Fungi and how it might actually be usable for you guys as a maybe, not really, as a Three.js replacement in the future. All right, see you guys in the next video.